So after we learn about how to write an equilibrium expression, how to understand a chemical reaction which is an equilibrium reaction, now we are going to look deeper on what is the K value, what's the equilibrium constant telling us about the reaction. So here we have two examples. First, we have acetic acid, CH3COOH. The equilibrium constant is 1.8 times 10 to the negative 5. Now, you can see here that the subscript A here, it is different from what we saw in the past. In the past, we saw Kc, subscript C, because it stands for concentration. Now we use a subscript A. So why is that? Well, we use different subscripts to stand for different things, but they still mean the equilibrium constant. But we just want to be more specific on what are we talking here. So if you see a subscript A, it means that we are talking about an acid, and acetic acid, CH3COOH, is what we are trying to look at right now. So 1.8 times 10 to the negative 5, meaning it is the same as 0.000018. So it is a pretty small number. But if you look at this one, calcium phosphate, it has a equilibrium constant value of 2.0 times 10 to the negative 29. It means that you have 0 point and then 28 zeros following the decimal point, and then you have 0 following the 20 zeros. So that is an extremely small number. So what do these numbers tell us? Well, if you remember what we said in the previous tutorial, we said that for the K value, it is going to be product over the reactant. For K value to be big, we have two possibilities. One is that if the product is going to be very big, it will make the K as a big value. If the reactant is going to be very small, which is in the denominator, it is also going to make the K value very big. So if you think the other way, if the numerator, which is the product concentration, is going to be small, the K value will be small. If the concentration of the reactant is going to be huge, then it's going to make the K value very, very small. So we can use that concept to understand what is the meaning of the magnitude of the K value. So if you compare these two, what we could say is that the number of ions in terms of concentration in molarity is going to be dramatically different. Here it is 10 to the negative 5 magnitude. This is 10 to the negative 29. So we would expect to see more concentration of the ions right here than we can see in here. This is how we make use of the equilibrium constant to help us to see how many products we are getting. Okay? And we always use this to compare the strength of an acid or base, or how soluble is a compound. So if you want to compare the strength of an acid, well, if you still remember what we said in the past about the strength of an acid, strong acids means that it is going to be completely dissociated into ions. And for weak acid, it is going to slightly dissociate or partially dissociate into ions. Now, if it is completely dissociating, that means we have a lot of ions. And if that is the case, then we will have many products. The concentration of the ions will be huge, and that turns out to give you a very big K value. If you have a slightly dissociative acid, or we can say a weak acid, then we would expect to see a small amount of ions appearing on the product side. And that is going to tell you about the strength of the acid. So if we want to compare the strength of an acid, whichever has a bigger value of the K, it is going to be the stronger acid. Or if you want to change acid to base, whichever have a larger value of the equilibrium constant, Kb, for the base, it is going to be a stronger base. And in terms of the Ksp, now Sp stands for solubility product. It is applied usually on the slightly soluble compound. If you have a number such small, it means that it is extremely barely soluble, close to insoluble. It only produces a small amount of ions, which is very hard to observe. And if you have a big number for the KSP, it means that it is quite soluble in an aqueous solution or in water. So this is how we make use of the equilibrium constant to tell us what is going on in the equilibrium expression. So keep this in mind. If you have a big K value, it means that you have a lot of the products on the equilibrium reaction. And if you have a small value of the K, it means that you have mostly the reactant. You only have a small amount of the product existing in the equilibrium expression. So this is going to help you to determine the strength of an acid or base, or how soluble a solid is in water or aqueous solution.